All right, good evening and welcome to mathsatoka online class. In today's video, we'll be solving calculation on equilibrium of forces. Okay, don't forget that we have a full video on equilibrium of forces. The link is in the description. Just check the description, you see the link. Okay, we have done a full video on this. Now we are just here for the calculation and we are solving fundamental physics. This is 100 level first semester physics. Okay, we are still in chapter 4. I'll drop the link for the other ones you have done. We have done chapter 1, chapter 2, chapter 3. Chapter 1 we did dimensional analysis. Chapter 2 we did vector. Chapter 3 we did vector analysis. There we are now in chapter 4, which is equilibrium of forces. So please, if today is your first time of watching our video, please click that red subscribe button, okay, so that anytime we drop a beautiful video like this on physics, chemistry, maths of WAEC, JAMB, NECO and university physics, maths and chemistry, you will get the video. All right, so now let's continue with this. Now to do this is very simple. They gave us the three sides of a triangle. If you look at that, this one is like this one is like this, then the other one is going to cover this way, right, which is this one that is slant. This one that is slant is tension T, and this one is 40 newton. Why this one standing like this is what? 6 kg, and 6 times 10 will give you what? 60 newton, because kg is mass. The mass is equal to what? 6 kg. So the weight will now be what? Mass times acceleration due to gravity, which is 6 times 10, which is what? 60 newton. Now if I now use Pythagoras theorem to solve this, I'm going to have that t squared is equal to what? 60 squared plus 40 squared. So therefore t squared is equal to 1600 plus what? 4 squared. Sorry, 3600 and 1600. All right, so t squared is going to be 40 squared plus 60 squared. So I'm having 5200. So 5200. So my t will now be the square root of what? 5200. So I'm going to have the square root of my answer. I'm going to have approximately 72. So this is 72.11 newton. So that is that. We move to the next question. So the next question, question number 2. So question number 2 said, define the moment of a force about an axis. Okay, please drop the answer at the comment section. Define it for me. The moment of a force about an axis. I will need the answer at the comment section, right? So we're going to solve calculation of number 2, which said a uniform 1 meter metal rod, okay, of mass 50 kg is suspended horizontally by two wires attached at the 20 cm and the 90 cm respectively. Okay, from the ends of the rod. Then I say calculate the tension in each wire. Okay, calculate the tension in each wire. Now if you look at this is very, very simple to calculate. Now what do we do? Let us draw the thing. Solution. Now drawing it, I have that I have this now, and they say that this is a 1 meter. 1 meter is something as 100. So from 0 to what? 100 cm. Okay, so why did I leave it in cm? Is because the rest are in what? In cm. This is cm, this is cm. So they now say that what? That the mass of this thing is 50 kg. So the weight is going to be 500 newton. Okay, and the weight of an object is always at the center. So this is the weight, which is 500 newton. So the next thing they told us is that what? That two string is attached at the two ends. Okay, so this is the first one. The first one was attached at 20 cm. So from here to here is what? 20. So if from here to if from here to here is 20, then from here to here will now be 30. I hope you know. This is 30. Here is 50. Sorry, this is the middle, 50. Okay, So this is 20. So here to here is giving me 20. So the other one was at 90. So this one was what? At 90. So if this one was at 90, if here is 90, 90 minus this here is 10. 90 minus this here is what? 40. Okay. So what else did they ask us to find? They now say we should calculate the what? Calculate the tension in each of the wire. So the tension in each of the wire goes like this. This is tension 1, and this is what? This is tension 2. Right? So to calculate this, we are going to have that. Let's assume that the first one, taking the moment of this one, let's assume that this one is not here, so that the weight of everything acts on this particular one. So that is how you do it. Okay, so that is if you want to get your T2. But if you want to get your T1, you assume that this one is not here, so that all the weight will act here, anyone you like. So now if I assume that this tension, this one is not here, or now let's let everybody act here. If everybody is acting here, you are going to see that this one is like this and this one is like this. All right, so these are the two distance that is there, the two forces that are there. So now the first one, T1, you see that T1 times the length from here to this point is what? 30 plus 40, which is what? 70, is equal to what? 500 times the distance from here to here is simply just 40. So you're going to have that your T1 is equal to 500 times 40 now divided by 70. So you're going to have 500 times 40 divided by 70. 500 times 40, sorry, 500 times 40 divided by 70. So I'm going to have 285.71 Newton. Okay, now you are going to do the same thing for the other one, or you say that total upward force is equal to total downward force. So you can say that your T1 plus T2 must be equal to the only force down is what? 500. So if you now put it, you see that 285.71 plus T2 is equal to what? 500. So therefore T2 will now be 500 minus 285.71. So you now have that your T2 will now be equal to 500 minus my last answer. So 500 minus, sorry, 500, right, my calculator is malfunctioning. 500 minus 285.71. So I'm going to have 214.29 in Newton. So that is that for the tension of the two strings. All right, so we move to the next question, question number 3. So question number 3 said that what? A 5 meter wooden platform is suspended from the roof of a house, by ropes attached to its ends. Then I say a carpenter weighing 800 Newton stands 1.5 meter from the left end of the platform. Then I say if the weight of the platform is 150 Newton, then I say calculate the tension of each of the ropes. Okay, so to calculate the tension of each of the ropes, first of all we need to draw it. If you cannot draw it, there is no way you will get it. They say that a 5 meter, so from here to here, this is from 0 to 5 meter. Okay, and don't forget that the weight of an object is always at the middle. So the first weight they gave me, where is the weight? They said that the weight of this platform is 150, so 150 should be at the middle, and the middle is here is 2.5. all right, then I say that a carpenter of weight this stands at the 1.5. So if the carpenter is here and the weight of this carpenter is what, 800 newton, and the carpenter stand at 1.5, so this minus this will give you 1.5, while this minus this will give you 1 meter. Okay, 1.0. So now we now have that, what again they say, they now say that okay, a 5 cm wood platform is suspended by 2 ropes at the string. So this is the first rope, is suspended by 2 attached at the ends. So the first rope, this is the first rope, this is the second rope here. So we have tension 1 and tension 2 at the end. So the same thing is applicable here. So let's calculate the first tension and the second one. So calculate the first tension. We assume that this is, that everybody is acting here. So this one will act here and this one will equally act here. So we are going to have that T1 times, from T1 to this point is 5, times 5 is equal to what? 150 times, from here to this point is 2.5. So 150 times 2.5, okay, plus 800 times, from here to here is 3.5. 1.5 plus 1.0 plus 2.5, which will give you 3.5. 3.5. So what do we have now? We now have that 5T1 is equal to, multiply 150 times 2.5. I'm going to have 375 plus 800 times 800 times 3.5. I'm going to have 2,800. So you now have that T1 will now be, add the two of them, plus 375. I'm going to have 3175 now divided by 5. So my T1 will now be divided by 5. I'm going to have 635. Okay, so the same thing is applicable. You now tell them that what the upward force, all the upward force is T1 and T2 must be equal to the downward force. All the downward force is what? 800 plus 150. So therefore this one is what? 635 plus that T2 is equal to 950. 950. So my T2 will now be what? 950 minus 635. So therefore my answer will now be minus 950. And I have what? 315 Newton. So these are the tensions at the two ends. Okay, so we move to the next question. Question number 4. So question number 4, they say what is meant by a couple. So you can define that for me at the comment section. Define couple at the comment section. So let's solve question for number 4. Said if each of the forces in a couple is 50 Newton and their lines of action are separated at a distance of 80 cm. Okay, they now say calculate the work done by the couple. The work done by the couple in turning through 4 revolution. Okay, solution. Now question number 4. Okay, now for question number 4, they say we should calculate now the first thing we should have is and they gave us that the force, they've given us force, that force is equal to what? 50 Newton. So what else they give us? They gave us our distance. So our distance r is equal to what? 80 cm, and 80 cm is what? 0.8 meters. Okay, so they now ask us to calculate this thing. We should calculate the what? Calculate the work done by the couple in turning 4 revolution. Now for it to turn 4 revolution, the work done simply means work done. The work done is equal to what? Tor times our theta. Okay, Tor times our theta. Okay, so now what do we have now? Our Tor is equal to force times the distance. Okay, Our tau is equal to what? F times R, then times the theta. So what do we have? 50 times 0.8 times our theta is going to be that is 22/7. That is our pi. Okay, yeah, 22/7. We have that s is equal to r theta, the arc distance. So but the tau is equal to fr theta. So I'm going to have, so we are going to have times 22/7. So I'm going to have what do we have now? 4 revolution means a complete circle. Don't forget, 4 revolution means a complete circle. Okay, that is 4 revolution. That's why we're using just pi here. Okay, so we now have that if you do everything, you're going to have that 1005.71 joules, right? So that is that. We move to the next question. Question number 5. So question number 5 said, distinguish between center of gravity and center of mass of an object. So do that for me at the comment section. Tell me the difference between center of gravity and center of mass. Then I say, with one example in each case, explain what you are explaining is: number 1, stability; number 2, stable, unstable, and neutral equilibrium. So explain that at the comment section. That is question number 5. We move to question number 6. Question number 6 said a beam of length 5 meter has weight 200 Newton, hung at one end and 150 Newton at the other end. Then I say neglecting the weight of the beam, itself. Then I say calculate the balance point of the beam. Okay, now to calculate the balance point of this beam, now we'll look at this. Let us draw a solution. Drawing it, I'm going to have that I have this. Now then I say that a beam of 5 meters, so from here to here is what? 5 meters. Now then I say that the other weight 200 Newton. The first weight here is 200 Newton, so this is 200 Newton, but I don't know where it is. And then the other one is let me say the other one is here. Okay, or let me put them at the both end. They say they are at both ends, so let me say that this one is what? 200 Newton, sorry, at the end. Then the other one is what? 150 Newton, at the other end. So we are now asked to find the balance point. That is, where do you think our knife edge will be so that these two things will balance? So I can say that from here to here, let from here to here be equal to x. Okay, if from here to equal to here is from here to here will now be what? 5 minus x. Is it not true? Because if from here to here is x and from here to here is 5, so here will now be 5 minus x. So you now do the clockwise moment and anti-clockwise moment to get our x. So therefore I'm going to have that 200 times x is equal to what? 150 times 5 minus x. So therefore 200x is equal to what? 150 times 5. 150 times 5. I'm going to have 750 minus 150x. So this one coming here, 200x plus what? 150x is equal to 750. So this plus this will give you 350x is equal to what? 750. So x will now be what? 750 divided by 350. So therefore you have that what? Divided by 350. So I'm having 2.14 in meters. So that is that. So it's going to balance at what? 2.14 meters. So that is that. So we move to the next question. Question number 6. Question number 7. That is the second to the last question for this topic. So question number 7 said, in the figure in the figure below, they now say calculate the weight of the block, B, okay, necessary to keep the object A in what? In equilibrium. Okay, so now we now have the figure below. We have this triangle like this. I now have a tire here, and this tire move this way. Coming to this place, there's another tire here, connected here, and then I have a block here. This is block B. I have that here is 30 degrees, and then I have that the weight of this one is 30 grams. All right. So for question number 7, this is very, very simple. It will make up a triangle. As simple as that. It's going to make up a triangle. So if you look at that, you're going to see that for the triangle solution, is already a triangle. So for the triangle, I have that this is the triangle. Okay. And here is my 30 degrees. So I have that the weight, which is acting downward like this, is 45, and this weight is the horizontal weight that is like this. I hope you know that this thing they wrote here is the way that is moving this way. Okay, so I'm going to have that this is 30 gram, and 30 gram converting it to Newton is the mass they gave me there is what? 30 gram, which is what? 30 divided by 1000, which will give you 0.03, okay, kilogram. So converting it to Newton is going to be 0.03 times this. So the weight will now be what? 0.03 times 10, which is what? 0.3 Newton. So here is 0.3 Newton. Okay, so we need to calculate the weight of this block. The weight of block B is coming here, which is X. So you now have that opposite over hypotenuse. That sine 30 is equal to what? Opposite over hypotenuse, 0.3. So you now have that X will now be what? 0.3 sine 30. So you now have what? 0.3 sine 30. 0.3 sine 30. I'm going to have 0.15. So I have 0.15 Newton. So that is that. We move to the next question. Question number 8, which is the last question I'm going to solve here. So question number 8. So question number 8 said a uniform ladder. A uniform ladder of mass 100 kg, okay, leans at 60 degrees to the horizontal against a frictionless wall. They now say calculate the reaction on the wall. Okay, so the reaction on the wall is very, very simple. So now I have this is the wall, and the ladder is leaned like this. I have my horizontal ground, all right, and it makes an angle 60 degrees with the horizontal. And then they say the mass of this ladder is 100 kg, which is what? 1000 Newton. So the weight of this ladder is 1000 Newton. So the tension here, the reaction here, is the tension that we're looking for. This is opposite over hypotenuse. So I'm using sine theta. So I have that what? That sine theta. Let me write here. That sine 60 is equal to opposite r over hypotenuse 1000. So therefore my r will now be what? 1000 sine 60. So what do you have? 1000 sine 60. 1000 sine 60. So I'm going to have 866.025 Newton. Okay, which is approximately 866 Newton. So that is that. for that. So thank you very much for watching. Please don't forget to like this video and comment. Please, the more you like and comment, the more YouTube recommend it for other people to watch. Please, or your like, or your comment, or your subscribe. Bye bye. Thank you very much.